Research computing provides several types of storage. Understanding these storage options, how they impact job execution, and how they may impact other running jobs is essential when running in the research computing environment. The first storage option is the home directory. Each user has a home directory available from all research computing nodes at /home/$user. Use your home directory to store scripts, code, and very small files. Home directories are limited to 2 GB. This prevents the home directory from being a target for job output, software installs, or other data likely to be used during a compute job. Home directories are not intended to be written to during a compute job because they are not stored on a high-performance file system. Use of a home directory during a high-performance or parallel compute job may negatively affect the environment for all users. Home directories and their subdirectories contain hidden snapshot directories. These contain recent copies of the files at 2-hour, daily, and weekly intervals. Use snapshots to recover files after accidental deletion or corruption. Home directories are intended for use by their owners only. Users are strongly discouraged from sharing the contents of home directories with other users. Home directories are backed up to a second site each night for disaster recovery, and are protected by the redundancy features of the 1FS clustered file system. The second option is the projects directory. Each user can access a 250 GB projects directory from all research computing nodes at /projects/$user. The projects directory is intended to store software builds and smaller datasets. Project directories may be shared with other research computing users. Project directories are not intended to be written to by compute jobs. Significant I/O to a project directory during a high-performance or parallel compute job may negatively affect the environment for all users. A hidden snapshot directory is available in each project directory and subdirectory. These contain recent copies of the files at 6-hour, daily, and weekly intervals. Snapshots can be used to recover files after accidental deletion or corruption. Project directories are backed up to a second site each night for disaster recovery, and are protected by the redundancy features of the 1SF clustered file system. The third option is Summit Scratch Storage. This is a high-performance parallel Scratch file system meant for I/O from jobs running on Summit. It is available at /scratch/summit/$user. This storage space is most likely to provide the highest I/O performance for jobs running on Summit and is the preferred storage target for these jobs. Summit Scratch Storage should be used to store output from running jobs, large files, and shared files. Each user is limited by default to 10 terabytes of storage space and 20 million files and directories. If you need more storage space, email rc-help@colorado.edu. Summit Scratch is mounted on all Summit compute nodes via the GPFS protocol over the OmniPath interconnect. It is also mounted on login nodes and data transfer nodes via the NFS protocol. High-performance Scratch directories are not backed up or checkpointed and should not be used for long-term storage. Data may be purged at any time. Files are automatically removed 90 days after their initial creation. Let me repeat that files are automatically removed 90 days after their initial creation. Inappropriate use of Summit Scratch, including attempts to circumvent the automatic file purge policy, may result in the loss of access to Summit. The fourth option is General Scratch Storage for Blanca. A central general-purpose Scratch file system is available at /rc_scratch/$user. This space is intended for short-term or parallel storage over the length of a job run. Its primary purpose is for I/O from jobs on the Blanca cluster. Summit compute jobs should use Summit Scratch rather than the general-purpose Scratch file system, so the general-purpose Scratch file system is mounted read-only on Summit compute nodes. No administrative limits are placed on the amount of data that can be placed in a general-purpose global Scratch directory. General-purpose Scratch directories are not backed up or checkpointed, are not appropriate for long-term storage, data may be removed at any time, and files may be automatically removed 90 days after their initial creation. The fifth option is local scratch storage. Local scratch directories reside directly on individual compute nodes and are assigned automatically during job execution. Because these directories are assigned and removed automatically, the location of the directory is assigned to the $slurm_scratch environment variable. No administrative limits are placed on the amount of data that can be placed in a temporary local scratch directory. Scratch directories are only limited by the physical capacity of their storage. Local scratch directories are not backed up or checkpointed and are not appropriate for long-term storage. Local scratch directories and all the data they contain are automatically removed when the running job ends. The final option is the PETA library, which is designed for long-term storage of large amounts of data. For more information on the PETA library, follow the link on screen.